in the circle. Okay, if you go around a loop in a circuit, as long as the loop is closed, if you add up the voltage drop in that loop, it has to add up to 0. Another way is that you can go around this loop and add up all the voltage drops. Okay, in that loop, they have to add up to 0. And you can also go around this loop. Okay, and count all the voltage drops, and they should also add up to 0. But you should notice that the larger loop is actually redundant because it can be made up by the smaller loops. Okay, usually you don't need redundant loops. You just count the loops that are independent of each other and write down Kirchhoff voltage law, and you should have captured all the voltage drops. Okay, this is one way to write Kirchhoff voltage law. Another way to write Kirchhoff voltage law is to count all the voltages that are rising plus all the voltages that are dropping. It's the same thing, okay, because if they're dropping, you will have given them a negative sign as you count them. So it can be equal to this minus that if you put them on the same side of the equation, but actually it's the same as the first law. Okay, same way of counting, and they should add up to each other. Okay, all the voltage rises and all the voltage drops should add up to each other. It's another way of saying Kirchhoff voltage law. What is Kirchhoff current law then? Kirchhoff current law. This name Kirchhoff is spelled differently by different people. This is how I spell it, but the Russians might spell it differently because it's Russian, I believe. Kirchhoff. How many ways can we spell your name? Maybe sometimes it's spelled this way. Sometimes it is spelled this way. I don't know. Okay, they all mean Kirchhoff because they are all transliterated from Cyrillic to Roman alphabets, depending on how you transliterate them. His name is spelled differently. Okay, so this is Kirchhoff voltage law and Kirchhoff current law. And Kirchhoff current law says something very simple, that if you have a node, all the currents that come into the node must be equal to all the currents that leave the node. Okay. Again, there are two ways of writing Kirchhoff current law. That if you have a node, if you draw all the current to be coming into the node, all the current that come into the node must add up to 0, or you can draw a picture where all the currents are leaving the node. Okay, they must add up to 0. This follows from charge conservation. Okay, since currents are due to charge flow, somewhere we say that current is due to charge flow. Okay, electrons moving around, they cannot be destroyed or created. So when they come into the node, they must leave the node. If they leave the node, it must be compensated by some of the currents that come in. And another way to write Kirchhoff current law is that all the inward flowing current must be equal to all the outward flowing current. Okay, there's another way to write it. Then you would draw a different picture to depict this. You have some current coming in, some current coming out in this picture. And for those that are outgoing, you put in on the right-hand side of the equation. For those that are incoming, you put in the other side of the equation. And this is Kirchhoff current law. Okay, are there any questions regarding this? We have about 10 minutes left. And if you don't have any questions, I can maybe do some details and examples with you. So, does anybody, yes?
I have some questions, but it's more about how the class is set up and not about what you just lectured on.
Okay.
Okay. You said the homework was due Wednesday. What's the format, or what tool are we going to be using to be doing online or in paper?
I believe you had in hard copy of the homework, right? Aditya was a TA last semester. Yeah. What did they do?
So the homeworks will be posted on the website.
Which website is that?
You can look it up. It's there.
Okay, so there's one online. We can
Yeah.
find.
So if you Google EC210, there's a website. So the homeworks will be put up on the website, and you're supposed to do the homeworks. And Wednesday 6 p.m. There's ground floor Everett lab. There are boxes for each of the professors.
So they have the handy hard copies, right?
Yeah.
Okay.
And
You
they have to
do
put
them
it
on
into
paper
the
and put them in the right pigeonhole, right?
yeah.
Somewhere in the Jordan faculty lounge. We go to the first floor and the this is southeast corner.
Professor, they have to submit it on the ground floor.
Oh, theirs is in the G floor.
Yeah.
Okay, there are also some TA's facilities on the ground floor, this building, which is below the first floor. There must be cubby holes there for them to drop the
Yeah.
homework in. So you look for the one for EC 210.
And
So our first Wednesday 6 p.m. is tomorrow. So we're
no. The homework will be due. But we haven't given out any homework yet.
Right.
Okay, there's no homework for tomorrow. Okay? So you don't have to worry. Any other questions that you may have before the time is up? Yes?
Homework from the textbook?
Yeah, they should be from the textbook, right? Or from professors?
Not necessarily. So professors.
Okay,
propose the
professors
homeworks.
assignment. Okay, so you have to get them on the website. Yes?
Grading policy.
Grading policy, this is the first time I teach the course.
So-
What is the grading policy?
Yeah, and how many tests do
More
we
to the
have?
point, is there a syllabus on the supposedly posted website?
Yes.
There's a syllabus, yeah, there's actually a course outline. Okay?
So, what is your question?
Is there a syllabus?
Oh, grading policy. So all the information you need is available on the website. You can go look it up. And any communication that will happen is going to happen on the website.
Just for us, would it be possible for you to get the URL of the website for next lecture, so we all make sure we're going to the right one?
Okay. URL, you have the URL?
You can Google it, right?
I visited it, but I didn't record it in my brain.
Oh, yeah. It's courses.engr.illinois.edu/210/EC210.
Okay.
And where we can get that?
What are the things before here?
Courses.engr,
Courses.engr.
yeah, .illinois.edu.
.edu.
Yeah. /EC210.
ECE 210.
Yeah.
Okay, anything before it or just dot?
HTTP, www.
Okay. Courses.engr.illinois.edu/ECE210. Okay, that's a course website. Yes?
If we miss a lecture, can we go to a different professor's lecture? Or they
Yeah, I don't take attendance, so I wouldn't know if you miss a lecture or not. So you can go to the other professor's lecture.
Are they gonna be synced up though, or are they totally different? Or
They should be in sync if they teach according to the schedule. We're given a schedule to teach with. Okay? So if all professors follow this schedule, then they should be in sync with each other. Maybe some people go fast. Okay? So, any more questions before I wrap up? So, you know that electrons are responsible for electricity, actually, and do you know how many coulombs does an electron carry? How many coulombs is associated with an electric charge? One electron has a tremendously tiny amount of charge. Okay? 10 to the minus 19. So 1 amp, which is 1 coulombs per second, okay, is 10 to the 19 electrons zipping past in your wire. So when you next time has a piece of wire that carries 1 amp of electricity, just imagine how many electrons are moving across that wire. They're zipping past in this number. Okay? And maybe I can just spend the last few minutes working out this problem. Say if you have the circuit that looks something like this, a B, an A, and then something like this, C, a D. And then you know that IC is 3M. And then you're asked to figure out what IB is. And you're given that IB is equal to 1M. Okay? What is ID, do you think it should be? What is the current through here? If you apply Kirchhoff current law, what is ID? Minus 2M, right? And what is IA? If you apply Kirchhoff current law, 1M, right? Because this current has to be equal to that current. So it's quite simple, okay? Circuit theory is quite simple. And you can figure out all the currents in the system, and the next thing for you to do is to figure out the voltage. And then if you are given the voltage at a certain node, okay, say if you're given that this is 4 volts, this is maybe minus 1 volt, and then this is 0 volt, then you can figure out all the voltages on the system, okay? And then you can actually calculate all the power on the system by using P is equal to IB on each of the elements. And you will find that this has to be true. PA plus PB plus PC plus PD must add up to 0 due to energy conservation. So some of these elements must be giving out power. Some of them are absorbing power. So some of these elements must be something like a voltage source, okay? Like the voltage cell that they used to telegraph it in the 1800s, early 1800s. And then the others are things that dissipate energy, like a resistor, okay? And some of them will be positive and some of them will be negative. And then I think I'll stop here. And there's the other example. Okay.